In this chapter, we'll go over the derivatives of carboxylic acids, their nomenclature, preparation, and their reactions. These are the five derivatives of carboxylic acids, and we call them derivatives of carboxylic acids because we start from carboxylic acid to prepare each one of them. Acid chloride has a Cl minus as a leaving group. And we know that the weaker the base, the better the leaving group. This makes acid chloride to be the most reactive derivative of carboxylic acid among all the carboxylic acid derivatives because the Cl minus is the weakest base among all the leaving groups of the carboxylic acid derivatives. To name the derivatives of carboxylic acids, we're going to name them as carboxylic acids because they are derived from carboxylic acid. And then we're going to modify on the name of the carboxylic acid depending on what type of functional group do we have. So for acid chloride, whether we are working with common or IUPAC, it goes by the same rule. You are going to drop the ic acid from the parent carboxylic acid name. And then you're going to add a YL, and depending on the halogen that you have, the halogen can be either a chlorine or it can be a bromine in there. So it can be either an ill chloride or an ill bromide. Let's start with this example over here. If you want to name this as a carboxylic acid, this is going to be ethanoic acid. So all what you need to do is go ahead and drop the ic acid out and replace it by a YL and a chloride. And that is going to be your IUPAC name. We're going to do the same thing for the common name. So for the common name, we know that this one is acetic acid. So again, drop the ic acid out and replace it by a YL, and then depending on the halogen that you are working with. Don't forget that whenever you are naming common names for long chains in there, the carbon that is connected to the carbonyl is alpha carbon. The one next to it is a beta. And then we have a gamma. And then we have a delta. And then we have an omega and so forth. We're just going to stop at the omega in there. So if I am naming this as a common name, always start numbering from the carbonyl because this is your functional group and they're going to give it the lowest number possible. If you replace the chlorine by an OH, then it will be a carboxylic acid. And this is what I would suggest, that every time you're naming a derivative of a carboxylic acid, just go ahead and replace the functional group by an OH. So you replace any one of those by an OH, name it as an acid, and then go ahead and follow the rules for that particular functional group. So over here, this is 1, 2, 3, 4, and 5 carbons. So this is going to be a pentanoic acid. You just drop the ic acid and add a YL chloride. Make sure that you have the substituent in there together with the number where it is on the chain. For the common name, do not use numbers. For the common name, if you use numbers, it is wrong. You have to use the Greek letters. You have to use the Greek letters in there. So here the methyl is on the beta carbon. So that is going to be beta. You either write it as beta like this, or you just write it like that, whatever you want. So that is going to be beta methyl. And then we know that a chain of 5 carbons is this is valeric acid. So if you have it as a chain of 5 carbons, this is valeric acid. So you are going to drop the ic acid out and you are going to add YL. So that is going to be a valeryl chloride. If you have a carbon pointing out of the cycle, this is not a benzene. So you cannot name this carbon as a benzylic. Pay attention. This carbon is going to be a carb, and since it belongs to a acid chloride, then it's going to be a carbonyl chloride. Now this carbon over here, it's going to be a benzoyl. because it is a benzylic carbon. See the difference between this carbon over here, which is connected to the benzene, and this carbon over here, which is connected to the cyclohexane. If you have any other functional group other than the carbonyl is going to take carbon number one. Because after all, this is derived from the carboxylic acid, and the carboxylic acid gets the highest priority. The alkene is going to be another functional group. Try to give it the lowest number possible after you give the carbonyl the lowest number, and that is going to be 3-butanoyl chloride. Don't forget the E in there just to indicate that we have a double bond on carbon number 3. Now, because here I don't have any stereochemistry between carbons 3 and 4, we didn't put the stereochemistry, but if you had stereochemistry, you have to indicate if the double bond is E or C. If you have two acid chloride groups, then the ending is going to be a di-oil chloride. We mentioned last time we are going to keep the E in there because the di separates the E from the O. And the rule is that you cannot have two vowels next to each other. So once you have the di as a separation, you can keep the E. This is called adipoyl chloride as a common name. You are not responsible to name that as common. To name anhydrides, there are two types of anhydrides. There are symmetrical anhydrides, and symmetrical anhydrides meaning that you have groups that are the same on both sides of the carbonyl. So here in this case, you have a benzene, here you have a benzene. So these two R's are the same. We know that the anhydride part is the carbonyl, the oxygen, and the carbonyl. This is the anhydride part in there. So this is going to be fixed. It's not going to be changed. What's going to be changed are the R groups around the anhydride. So if the R groups are different, then in this case, this is called a mixed anhydride. And then we have a third type of anhydride, which is a cyclic anhydride. Just don't confuse this with the ester. This one is an anhydride because, again, we have the anhydride functional group, which is the carbonyl, oxygen, and then another carbonyl in there. This is not an ester in there. So you cannot say that this is an ester and this is a ketone. You cannot separate those two bonds from each other. This whole thing is one functional group, which is an anhydride. So now to name symmetrical anhydrides, so what you need to do is just name the acid that is derived. This is symmetrical, so I know that the acid that this anhydride is derived from is this acid over here. Okay, and this is going to be a propanoic acid. So that is going to be a propanoic acid. Okay. Now this is the only type of acid in there because the R is the same. So all what you need to do is simply drop the acid and add anhydride. So when you look at the name and you see that there is only one R in there, this means that this R is twice and this is a symmetrical anhydride. Same thing over here. This is going to be an ethanoic anhydride. This has a common name. Instead of acetic acid, you drop the acid out, and that is going to be acetic anhydride as a common name. To name anhydrides that have different R groups. So the R group here is different than the R group in there. First, you're going to name their acids. So this one comes from an acetic acid, and this one comes from a benzoic acid. You arrange the acids in alphabetical order, you drop the acid out, and you add the anhydride. So that is going to be acetic, benzoic, anhydride. There is a space between acetic and benzoic in this case. Here you name this side over here. You name this side over here. So this is derived from a pentanoic acid. You drop the acid out. This is derived from a benzoic acid. You drop the acid out, and then you arrange them in alphabetical order. B comes before the P. Don't put them as one word in here. Please make sure that you have a space in there because these are two separate acids that normally we combine them together to get the anhydride. Now, to name esters, the first thing that you would need to do is name the R group that is connected to the oxygen. This is the first thing in there, and this is the first thing in the name. Okay, so when I look at the name, I have the R group in there, so I know that next to the oxygen there is an ethyl group, which is 2 carbons. After you name the group that is connected to the oxygen, now you are going to name the rest of the ester molecule. Starting from the carbonyl, always start from the carbonyl and count the carbon of the carbonyl in there. This is how my numbering is gonna be. You're gonna name it as an acid derivative, and then you're gonna drop the ic acid out and replace it by ATE. So this is going to be butanoic acid. You drop the ic acid out. So it's going to be butanoic acid. Drop the ic acid out. Keep the O. And you're going to replace it by ATE. So it's going to be butanoate. This over here is a 2 ester molecules in there. Okay. So whenever I'm working with 2 ester molecules, I need to differentiate this from that. So 2 ester molecules, I need to use the prefix, which is di in there. So I start first by naming the group that is connected to the oxygen. So here I do have a diethyl. And then you are going to choose the longest carbon chain, including both carbonyls in there. Okay, this carbon chain is made up of 3 carbons. This is 1, this is 2, and this is a 3. So that is going to be a propane. And then since I have 2 esters in this case, I need to use the prefix di. Instead of saying dioic acid, you drop the ic acid and put ATE at the end. So it's going to be dioate, ATE. To name cyclic esters, we are going to use the Greek letters in there. So cyclic esters are always named as common name and not IUPAC name. And their common name is a lecton. So to determine whether our cyclic ester is a 3-membered ring, 4-membered rings, or 5-membered rings, we need to look at the carbon that is connected to the oxygen and see what Greek letter is that. So over here, this carbon is a gamma. So gamma means you have a cycle of 5-membered rings. So that's going to be 1, this is going to be 2, this is going to be 3, this is going to be 4, and the oxygen is going to be 5. So we call this a 5-membered ring in there. If you have a 6-membered rings, then this is going to be called a delta. So that is going to be called a delta lecton in there. If there is any substituent, since we are naming those cyclic esters as a common, just determine on what carbon that substituent is and make sure to put the Greek letter that corresponds to that position. If I want to name this ester, for example, over here, so this is going to be my ester, then this is going to be the alpha carbon, this is going to be the beta carbon, so that is going to be a beta lactone. So a beta lactone is a cycle which is made up of 1, 2, 3, and 4-membered rings. Now let's say, for example, if your R group that is connected to the oxygen is a long carbon chain, then in this case, you are going to name it as usual, but you are going to start numbering always from the oxygen in there. Choose the longest carbon chain, like you name the regular alkane in there. Name your substituent or number your substituent. So that is going to be 3-methyl. It is a butyl in there. Remember that the group that is connected to the oxygen, you have to name it first. So you name that first, and then you name the carboxylic acid that derives the ester. This is benzoic acid. Drop the ic acid out and replace it by ATE, so it's going to be benzoate. This one is going to be a tertiary butyl. It is a cyclohexane, and it is not a benzoic. It is a carb, and because it is an ester, we're going to call it a carboxylate. Tertiary butyl is considered to be a common name. So if I want to name it as an IUPAC, that is going to be a 1,2. So this is going to be a 1,1-dimethyl ethyl. Okay. And then it's going to be a cyclohexane carboxylate. To name amides, we're going to divide them as primary, has its own rules, and then secondary and tertiary has their own rules as well. So to name the primary amide, we are going to replace any acid ending, any of those acid endings with the amide. So you name it as a carboxylic acid. This is acetic acid. You drop the ic acid out, you replace that by an amide. This is benzoic acid. Again, you drop the oic acid out now, and you replace it by an amide. Over here, this is, if you want to name it as a carboxylic acid, it's going to be 2-methyl. It is a cyclopentane carboxylic acid. So now you are going to drop the ilic acid out and replace it by an amide. So it's going to be a carbox amide. Primary amides are amides that are connected to only one carbon. Secondary amides, on the other end, those are connected to two carbons. The nitrogen is connected to 2 carbons, and tertiary amides have their nitrogens connected to 3 carbons in there. It differs in the name if I am naming a primary, secondary, or a tertiary amide. So in order to name a secondary or a tertiary amide, the first thing that you do is like the ester. This is like the ester. So you're going to start first by naming the group that is connected to the nitrogen. Here I do have one group that is connected to the nitrogen for the case of the secondary amide. For the case of the tertiary amide, I have 2 groups that are connected to the nitrogen. Of course, you ignore the carbonyl because later on you're going to put the name of that carbonyl and any other group that is connected to it. Just name those 2 groups first in there. This is going to be an ethyl. The ethyl is on the nitrogen. So I have 1 R on the nitrogen here. So this is why I represent this by 1N. 1N indicates that I am naming a secondary amide. If I have 2 N's, then this indicates that I am naming a tertiary amide. So here I do have an ethyl group and a methyl group. The ethyl comes first. So the ethyl is on the N and the methyl is on the N. So this is why I need to give both of them N's in there, but they are separate because the methyl is different than the ethyl. So that is going to be N-ethyl, N-methyl, and then we are going to name it as usual, as a carboxylic acid, and then we are going to drop the ending of the acid, and then we are going to add an amide. If you have 2 R's that are the same, as in this case over here, then you have to group them both together, put a comma between the N's, so that is going to be N-dimethyl. Those N's are very important because the moment I see 2 N's, I know that I am working with a tertiary amide. If I have 1 N, then I'm working with a secondary amide. If I have no N's in here, then I am working with a primary amide. Amides also can be cycles, and we need to differentiate the cycles of the amides from those of the esters. So esters, we call them lactones. These ones, we are going to call them lactams. The M over here stands for the amide in there. And we're going to name them exactly the same based on the connection of the nitrogen to the adjacent carbon. So if you have a beta lactam, then this means that this is a cycle of four-membered ring. I'm saying membered ring because not all the members in the ring are carbons. There are three carbons in there and a nitrogen. For the cyclic amide, the nitrogen is connected to the gamma, so it's going to be a gamma lactam. Since I have a substituent, if you want to name it as a full name in common, then you have to name it as an N-methyl, and then it's a gamma and it's a lactam. There are multiple ways to name nitriles. You can name them as simply a substituent of the alkane chain, so your ending is going to be in the alkane. Something like this. So you choose your longest carbonate chain, excluding the carbon of the CN. So now that CN over there, we are going to consider it as a substituent that is on carbon number one. So we don't count the carbon. If we do this, then in this case, your ending has to be just in the alkane. So the ending is going to be a propane. And you name it as usual. You have a 1-cyano, 2-methyl, and then it's going to be a propane. The, the other method is to consider the carbon of the cyanide as part of the longer chain. So you consider it in the numbering. In this case, your ending is going to be the nitrile. So what you're doing over here is dropping the oic acid out, and replacing that oic acid with the nitrile. But since the nitrogen is not a vowel letter, you have to return the E of the butane. So the name is going to be here 3-methyl. It's going to be butane nitrile. Same thing over here. It's going to be an ethane. Stick the word nitrile in there. This is derived from benzoic acid. So in this case, you are going to drop, here you're not going to drop the oic acid. You're going to drop just the ic acid out. So you drop the ic acid out because this is a common name. So you drop the ic acid out. So for the common, you drop the ic acid out. For the IUPAC, you drop the oic acid out. So it's going to be benzonitrile. Over here, this is going to be phenyl. It's an ethane. Instead of being ethanoic acid. So instead of being phenyl ethanoic acid, you drop the oic acid out, and then it's going to be phenyl ethane nitride. When you have a cycle, then it's easy to name the CN as a substituent, and the substituent is going to be a cyano. There's a big difference between a benzonitrile and a benzyl cyanide. Cyanide, when it is at the end, then the carbon is not part of the longer chain. Pay attention to that. So here, cyanide is considered to be a substituent. This is why at the end I have it as a cyanide. The benzyl is a benzene connected to a carbon in there, so I know that I have a benzylic carbon. There's a difference between this and that. This is benzonitrile. Benzonitrile, when my ending is nitrile, this means that the carbon of the cyanide is counted within the chain. And your chain is a benz. So benz means it's a benzylic carbon. So it's a benzene connected to a carbon. So I don't have any additional carbon in there. So this is why I'm naming this as a benzonitrile.